Today we'll be going over chapter sections 6.2 and 6.3, these being types of failure and the basic concepts of fracture mechanics. First off, failure is defined as having occurred when the plastic deformation reaches an arbitrary limit. In experiments and in calculations, we will look for the 0.2% offset in a standard tensile test. Looking at the graph on screen, we can see that from the yield strength point to the ultimate tensile strength point, it suggests that more yielding can occur without harm. Moving on, when talking about the failure of a loaded member, we can see it as any behavior that would cause that loaded member to be inadequate for its intended function. As of this chapter, we will be focusing on static loading. Static loading can lead to large deflection and elastic instability. Within static loading are two topics, which include plastic distortion and fracture. If we look more into the topics of plastic distortion and fracture, in most cases, materials that fail due to distortion are considered ductile. Materials that fail due to fracture but have not suffered damage from distortion are considered brittle. Although we would like these definitions to be clear-cut, due to certain circumstances, an example being low temperature, we find ourselves having to decide which type of failure the material falls into, as it can change depending on the circumstance. Moving away from theory for a second and into where we see this problem in real life is an example of structural steel. Engineers and metallurgists have conducted tests in the lab and determined that structural steel has characteristics of a completely ductile material, although in practice have seen fractures that indicate the brittle nature of the steel. With these ambiguities of the mechanisms of brittle fracture comes a new discipline to study, fracture mechanics.
Created using Pt2.